So my name is John Irvine, and I'd like to start off the industry club by saying a little bit about what we hope to get out of this for the community and how it relates to St Andrews and just to take our turn as one of the presenters. So the first question would be, what is an industry club? And the idea is that every month we might meet together and bring together a number of interested companies, ideally over coffee, and have a chat. That's not really going to happen for a few months yet, and in some ways there's a lot of advantages to doing things like this online. Well, could I ask you to keep muted, by the way, if you can? I'm not sure if that's background. So the idea is this is an opportunity for companies to get together. Hopefully St Andrews can work as a catalyst and get companies together, or indeed exchange research between St Andrews and developers, and also find ways that we can help and work together. So the industry club will normally be giving you access to where different companies are at, and LERG will be following me. And this will also help and shape the direction of the university's new Centre for Energy Storage, which we call Genesis, which, seeing as it's on the Eden, seems fairly reasonable. So the focus is really on clean energy, batteries, hydrogen. There's a big interest in low carbon mobility, catalysis around waste to energy and bioenergy, and also about electricity production, distribution, and storage. But really trying to make net zero happen, and to do it in a way that creates jobs and employment. So the industry club is a vehicle that will help you to get access to test and development facilities that we're hosting at Eden campus. There will be possibilities to organize meetings and events on the facilities that are being built on Eden campus, and to help with long-term collaboration and knowledge transfer and translation of ideas. Very important is business to business networking opportunities, and I'd like to see Eden campus as an innovation sandpit where various parties get together and work out problems to solve and make advances. And that innovation sandpit can be university to business, or business to business, or even university to university. So this is a diagram of Eden campus in a state of development. It's late last year, I guess. Currently, Walter Bauer House is where the university offices are being relocated, and if it wasn't for COVID, those would now be occupied. If you go across, I think you maybe see the cursor, you come across to the Centre for Energy Engineering and Advanced Manufacturing, Genesis Centre for Energy Storage and Conversion, and Eden Enterprise Hub. And for those of you who know the area, these are the buildings backing onto the road that goes through Guard Bridge to St Andrews. Just to show that things are looking a bit snazzier, this is at the end of the Walter Bauer House, and that building is now fit for purpose, and we're hoping that the rest of the campus will follow in the coming year or so. So within next year, we will have facilities for batteries and energy storage devices for developing and testing, fuel cells and hydrogen, bioenergy conversions, and electronics, photonics, and sensor devices will be also developed on site. We're going to offer a space, co-working space for member and user companies. There's funding for an enterprise hub for startup and grow on space. There's seminar and meeting rooms, and there's indeed a place to have coffee, or perhaps, if we're not driving too far, a place to have a beer on Eden. So the focus is on research to market, and there are two pinch points. One is between research and innovation, and scale up innovation, and then there's some innovation to commercial market. And we're very keen to drive all these forward, but I think it's fair to say that Genesis and Eden is very much on the low TRL translation, and our neighbouring and partner organisation, MSIP in Dundee, focuses very much on translating innovation into commercial market. And we think there's a really nice synergy that's almost been serendipitous, but I think it gives us a very clear objective of the way forward and the Tay Cities region pathway. So in terms of interaction, there's this industry club, which is really a way of meeting and getting to know with each other. The Genesis Centre will have facilities for developing technology. We house the Hydrogen Accelerator, which I'll say a few words about in a minute, but it is a Transport Scotland initiative. And there are two currently development activities that are there for companies to use. The main purpose is translation of innovation into companies, especially from the research sector. So one is the Hydrogen Interaction project, which was recently funded, and the Energy Demonstrator on Advanced Manufacturing call a bit earlier, and now that's underway and has been ordered. So in terms of Genesis, so there's generation, storage, innovation, and sustainability. You can look at a map of where we see our strengths and our interests, and where we hope to be able to work well with companies. So that's in developing energy materials and batteries, fuel cells and hydrogen, and biotechnology or bioenergy and synthetic fuels. And in each of these, we have testing facilities and fabrication facilities. And in the centre, we have offices, meeting rooms, and co-working space. And this goes on in an ecosystem in the east of Scotland, and indeed all of Scotland. And it's very important that we tie this in nationally. In terms of Genesis, I can see that the role is looking to companies with new products close to market, or those looking to develop new solutions. That feeds into the Genesis Centre. University research, know-how and expertise comes into that also, and they work together. Then we have test and demonstration workshops, analysis and verification labs, and scale-up facilities for manufacture. So hopefully, if it's a small company wanting a bit of a leg up to get started, the Genesis Centre would provide a very good home for the initial stages of developing, say, a new company or a spin-in. Outputs would be jobs, and I think key is that we have a core staff that's local, trained and expert, and that's something that that we can offer and seek to offer in Scotland, in places like St Andrews or Dundee, where there's a very skilled workforce available, and often a need for reskilling. And with the oil and gas industry translating into renewables, this is probably more universal. We look at scaling up towards manufacture, and the key thing is to bring products closer to market. So a couple of examples. First of all, on hydrogen, the Hydrogen Accelerator is an organisation that has recently been set up by Transport Scotland. It's very much about policy, removing gaps and enabling activity. So it's really getting technology rolled out. And we work very closely with Scottish Government, and we try and bring together the councils and companies to develop new hydrogen technology. So we can provide expertise, especially on things like safety or learning from past mistakes. Our team will give support. We will try and coordinate and bring together key initiatives. For example, the rollout of buses, or indeed the hydrogen train development that we're involved in. And the idea is to deliver decarbonisation and jobs in Scotland. And the role, first of all, technology assessment. So you need to do the right things. We'll help to optimise and standardise engineering, and that may be by finding appropriate partners. We'll also matchmake. So any sort of hydrogen rollout needs hydrogen production, and it needs hydrogen use as an absolute minimum. So you really want a cohort to deliver, and we will also be involved in outreach and communication of hydrogen. Following on from that, we've set up a technology support facility, which has recently been earmarked for funding, and we seek to buy in various pieces of equipment, and are still open to advice as to what small companies or companies might find useful to have access to, even if they can't own them themselves. So it's things like tape casting, screen printing. I think a 3D printer is now very high on the list, a 3D metals printer. And we will have furnaces, tape casters, it's a screen printer here available. So this is building to a larger scale than things that we have available in the university in the North Hall. We also seek to manufacture and test devices, and we will have capability for battery testing, as well as fuel cells, electrolyzers, gas handling, and there's also interest in a biomass converter, which is also related to fuel cell technology. The most advanced aspect is perhaps battery scale-up, and scaling up of batteries is something that is barely done in the UK. AMTE in Thurso are probably the only company that's really doing this. But there's a lot of interest in gigafactories and such things and the likes further south, and of course the likes of Toyota has got some capability as well. So there's a range of things. So electrode preparation, it's got 4 different steps: cell assembly, cell finishing. Much of this needs to be done in a very low humidity atmospheres. Water is really the biggest enemy, and we've developed facilities to do this in dry space. And we've just commissioned a dry room facility to be built, which will be coming online May or June of this year. So that's related to the genesis part of the Eden development. Within that, we've bought equipment from China, and we've got a full set of equipment such as calendaring, milling, casting, testing, and forming, electrochemically forming batteries. And this will be for prototype lithium and sodium batteries. The dry room has to be at least minus 40 degrees dew point, so very low humidity. Much of the equipment is in there that the calendaring will, from calendaring onwards, that will be inside. The casting will be in the next room, but also in a dry facility, but not quite as dry. And the idea is to take raw powder to finish pouch cells. And these are sort of going towards A5 type cells. It'll be 300 by 100 or 150 by 100. And it complements materials development coin cell testing. And this should be up and running in the summer. And it's not just that we want industry users, it's really focused as majority of the use is for industry developers. And we're very open to companies coming in and getting new chemistries manufactured over a week or two and showing that. This is all linked to research in St Andrews. So we have the underpinning research in the North Hall campus. I'll just say very little about that, but a lot of activity in materials for converting and storing energy and hydrogen technologies. So in terms of hydrogen, there's production is from electrolysis from steam, biomass conversion, storage as alternative fuels, final use, fuel cells for converting hydrogen into electricity, and battery technologies and silicon catalysis are also key to the North Hall activity. Research is generally on the production of chemically modified materials with enhanced performance. We've had some success in getting new materials into industry. Fuel redox stable electrodes are being developed in Switzerland at the moment, and a lot of interest in the nanoparticles we produce by Xsolution. It's got a lot of interest in catalysis as well as electrolysis. And of course, companies involved in Eden will have access to state-of-the-art facilities like electron microscopy and X-ray diffraction. So something that you might only use 1 or 2 days a year. We're very keen that you can come and access our facilities. And again, they're set up with a view to being open to industry usage. So yeah, we're very willing to talk, and the more we talk to industry, the more we learn about what the real problems are. So it's very beneficial to us and hopefully beneficial to people we talk to. So we've got expertise, facilities, and experience, and we still have capacity. Even with COVID, we're running about half full process. So you can contact us on Eden Campus or H2 Accelerator, Hydrogen side, and there's also the website. And I guess these slides will be shared afterwards. So I think we're open for questions, and I'll stop presenting myself, and either Sneh or Jeff can take over for the next bit. But I think we're open for questions. Not sure if Sneh wants to chair, maybe.
Sure. Yeah. Please either put questions in the question box or raise your hand if you've got any questions for John.
John, this is Jeff. I just had a quick question about the testing capacity on the SOEC side. When do you think that would be available?
We've got a high pressure facility. I was tried to include it, but I didn't have time. So we're probably talking about targeting the end of this year, have that facility up and running. So that's a Rolls-Royce facility. So that, yeah, by the end of the year for that facility. Depends on the scale of testing, what you want to do. I mean, we're already able to do sort of 100 watts at scale on site, but we're trying to build and make sure we have the right capabilities for people.
Sorry, there's questions coming in the text box. Just running a little bit slow. So Ed asks, what involvement engagement do you want from members in the future?
If we were in person, it would be very good to have team discussions and such things after these meetings. I think we're planning to try and go round robin with the main yeah, we're trying to get all our get a good number of our partners to present the case. The idea will be maybe have two presenters normally from allied areas who will create new ideas and suggest new collaborations. So I think worth considering having breaking off into groups this time, but as there's only one industry presenter, we decided we'd leave that till next time and get up and running. I hope helps, Ed. The Hydrogen Accelerator venue was set up in July of this year, so it's ahead of the hydrogen assessment strategy, and has been being prepared for about a year now.
Ian asks, what material synthesis capability do you have?
We haven't made the order yet, so I don't. Yeah, that's an interesting challenge because I don't think we will have the capability yet, but I think we'd love to make 5 or 10 kilogram quantities of materials for development. It seems such a stretch point in much development across fuel cells and batteries. George Curran's, yeah, there is an engineering workshop on site, and there must be. And the intention would be that will be for any companies that are working on site, they'd have full access to that, and I guess the industry club as well. So yeah, we tend to have a full engineering facility, and the 3D printer would be a start to that.
Okay. If there's no more questions, Jeff, would you like to take over and give us your presentation, please?
Sure, absolutely.
Would you like to take control of the slides, Jeff?
Okay, sure. So yes, the name of our company is Low Emissions Resources Global. We're located in Dundee, just on the other side of the river. And we're working on proton conducting ceramics, and we feel it's the future of green hydrogen production. Just see. So basically, what's our technology? We use electricity and water to produce pure hydrogen, dry hydrogen, and in an electrolyzer. We're creating high purity hydrogen synthesis technology that's virtually non-polluting when you couple it up with renewable energy. It's a sustainable product, it's scalable, and we feel it's going to be cost effective in the long run. We use proton conducting ceramics to create a proprietary cathode support, and we also use the same for our electrochemically active electrolyte and anode coatings. What makes PCCs important? It's going to be the next material used in the electrolyzer field. It's great for energy conservation, conversion and storage applications, as well as sensors and separation membranes. It has the efficiency and stability that we're looking for, and it has the ability to operate at low temperatures, and that makes it attractive in this field. Our company initially started off with a few scientists working in the St. Andrews lab space under John Irvine. We had about 300 square feet there where we did our material research and selection processes. We started working with how the material worked in different environments and operating conditions. And as the team grew, we moved into a 7,000 square foot facility in Dundee. And you can see we have a state-of-the-art facility there with all kinds of fume hoods and analytical equipment like an SEM and high-powered microscopes, dilatometers, and everything else under the sun in that facility. The LERG team has selected materials that meet the required performance parameters and understands their nuances to make them perform. So the team has been together for a long time. A good percentage of them came through Professor Irvine's group, and they work very well together. And really what that means to us is we can iterate through a lot of different experiments on site in order to make improvements real time and very quickly and try to get the results that we want out of our materials. We go from extruding the tubes themselves to dipping, coating, and firing right up through the test stand right there in one facility. So it makes it very quick and it makes data collection very reliable. Our next stage is that we've set up is really for our future and to support us. So we have a large group of strategic partners that we have under some sort of agreement or NDA, like Kyocera. They're one of the largest fine ceramic manufacturers in the world. They're very familiar with SOFC and SOEC. We work with Praxair to supply our powders coming out of Washington State. They do a lot of analysis and work for us in prepping those materials and make sure they come in under the right quality standards. And we have some other partners like Upstart Power and VHE. But what's really nice is we have 4 or 5 university partners, including the University of St. Andrews, that help us verify the data that we're doing and then also test our products in other environments and under different conditions. What we've accomplished so far in the last 2 years is, early we had a lot of hurdles with proton conducting materials. The fabrication of the materials was not that stable. It was difficult to get them to sinter properly. And then once we got past that hurdle of having them sinter and having the coatings adhere to the cathode, it became difficult to test them in the operating environment that we wanted to. But the perseverance of the team and the knowledge they had with the materials and the research they did and the collaboration they had with other universities and other partners allowed that hurdle to be cleared. And now we're testing cells in excess of 1,300 hours with very impressive performance numbers. And as you can see here in these pictures, the cells are well on their way to on the commercialization scale. And all these pictures are in-house, so we have all these testing capabilities in-house. We're trying to expand that, which is why what I thought Professor Irvine said about his future test capacity is very interesting to us. Once we felt comfortable that our cell technology was at a certain TRL level where it's robust enough and stable enough for it to be put through a number of different hurdles, we had to try to see if we could scale it up. So we partnered with Upstart here in the States. They have a lot of experience with stack development at the early stages. So we lengthened the cell, we improved the cap designs and the cathode interconnect designs, and we started to develop a stack. The center picture shows some early stack development that we went through, and then we made some recent stack improvements by beefing up the manifold assemblies and making it a little bit more robust. So those stack tests have been going on over the last 6 or 8 months. In the future, we'll continue to do stack tests. We'll work with Kyocera and Upstart to progress the stack design and hopefully make it more industrialized and commercialized. Kyocera is also working with our team in order to take our coatings and make them easier to apply to our cathodes and make them thinner and stronger. So Kyocera is actually engaged with us there in order to improve that technology. And then once we get stack design up and running, our goal is to have multiple stacks together and eventually get them into a pilot system of, say, a self-contained 40-foot commercialized electrolyzer. So I think we're open for discussion now. Like I said, we're located in Dundee, Scotland. Most of the staff came through Professor Irvine's group out of the University of St. Andrews, and we still have a great partnership with them in sponsoring some students and working with John and his group to advance our technology.
Thank you, Jeff. Are there any questions for Jeff or John at this stage, and topics that anybody would like to particularly bring to the front?
Jeff, can I ask about your hydrogen output from the technology? How pure is that?
Well,
in particular, how dry is it, and what?
Well,
what applications might you have in mind?
Well, what's nice about proton conducting is the hydrogen that comes out is pure dry hydrogen, so there's no contaminants of water or any other gases inside of it. Our initial, in talking to some potential future customers who are interested in investing in us and helping us grow, they're looking at using it on the front side of a Haber-Bosch process because it lends itself quickly to that, and then any other small portable hydrogen stations that require dry hydrogen.
Yeah, and Fischer-Tropsch as well.
Right. I see a question that says, what is your time scale towards having a commercial product? That's still to be determined. I would guess we're at least 2 years out from that. We've got a lot of work to do in verifying the technology and the data, coming up with an expansion plan. Most likely, we'll probably license out our technology. Since we're such a small group, it would be very difficult to scale at a rate that would make it feasible to actually produce electrolyzers themselves. That's why we've engaged with a company like Kyocera, who can handle the stack development and the manufacturing and fabrication of that process. And they're very interested in doing that with us. Like I said, they're already engaged with us in developing the process to coat our cells once we finalize that chemistry. See, it says, is financing a hurdle to reach your TRL ambitions? And if yes, how can St. Andrews Industry Help Club to secure both public and private or private financing? Yeah, we're always, as a startup, as a small startup, we're always in the fundraising phase, so to speak. We have 3 current investors that have been with us for about 4 or 5 years, and they continue to believe in the project and the technology. So they give us what we need for the short term in order to keep making advancements in the technology. But we are looking for a strategic partner in the field to come on board with us, and that's why we're talking to all of the bigger companies like the Nells and the Kyoceras, and even some of the oil companies that have types of divisions that are in them that are looking to have hydrogen in their portfolio in the future. So. Well, it says, what gaps do you think Scotland could fill in the supply chain, for example, to replace Kyocera? That's a good question. I'm not aware of any ceramic material suppliers in Scotland that can deliver what we are getting from from Kyocera, or actually the Kyocera is supplying the future growth of the manufacturing process. So I'd have to kind of research that. Kyocera kind of fell on our lap about a year and a half ago. We were able to establish a quick partnership with them. So, but I would be open to any suggestions if there was any Scotland based suppliers that could help us out with that, because competition in the space is always healthy for the company. When do we expect to reach the reactor pilot system stage? Our goal is to have that in sometime in 2022. We feel we can get through the stack development design stage and get cells that are robust and stable enough to move to that level. So that is currently slated for 2022, hopefully by the first half of that year. We already do have designs in place for that. We worked with a company, VHE, out of Iceland, that can do design and fabrication for balance of plant. So we do have that design in place based on the estimated temperatures that we were going to operate in, and the gas flows, et cetera, and the power requirements. So we're a little bit ahead of the curve on that side, on the small pilot plant, as far as designing it. So now we're just trying to work quickly to get the cells up to a specification that is worth putting it into a stack and then multiple stacks in a container. What are the ideal power conversion needs to convert hydrogen or to shuttle between hydrogen and or other energy storage technologies? I'm not sure exactly what the question is, but I mean, we're looking to hit numbers below 40 kilowatt hours per kilogram of hydrogen at the cell level. And we're currently in the mid 40s now, and we've got quite a number of experiments teed up in order to enhance that performance. Like I said, the team is fighting for space on the test stands in order to try out the next stage of development that'll lower that kilowatt hour per kilogram usage that we currently have. And the most exciting thing about happened in 2020 is the rate of improvements that we were able to make at the cell stability level and the performance level of kilowatt hours per kilogram. I mean, we were in early 2020, we were having cells on test stands of 10 to 20 hours before the degradation would quickly start to begin to move to an unusable cell with kilowatt hour per kilograms above 90 or 100 to make a kilowatt hours per kilogram. And we quickly moved past that in Q1, and we continue to make that progress throughout the summer, where we get stable cells in the 1,000-hour range with kilowatt hour per kilograms in the mid 40s. And basically what we're doing, because the limitation of testing and test stands, we're forced to pull the cells down at 1,000 hours or 1,500 hours only to get to the next test and do postmortems on the current test to figure out what the next improvement would be. It says, how flexible will the production process be? For example, will your process run continuously, or will it start and stop and then or go in reverse for H2 to power? We haven't tested H2 to power yet, so that's still out there as of course, something we want to try. But right now we're just focused on power to hydrogen. That's our main product category and what our investors are asking us to do right now. But it's not inconceivable that that is an option for us. But I can't really make any comments on how successful that would be. Our electrolyzer is being developed to run continuously. You can bring it down in order to compensate for renewable power cycling, but you have to leave it at temperature. So, that's one of the things. But a nice part of that is we are engaged, and we do have ownership in Upstart Power out of Massachusetts, and they've developed some technology around start and stop that we potentially may look at applying to our technology. John, do you want to take Jamie's question about what could Scotland do with, or Scottish government do?
I think things are starting to happen in a good direction. There's an election coming up, so I suspect there won't be that much happening for a few months. But the supply chain is something that's really important. If we're going to generate the amount of hydrogen that we could in Scotland, there's going to be a lot of electrolyzers needed. And that needs a lot of components. So it's not, and you also need the ability to really scale up and ramp up. And I think the possibility of the oil industry translating would be a really useful thing to both to deliver low carbon, but also to get jobs.
Yeah, we've had a lot of positive interaction with Scottish Enterprise, especially out of the Dundee office. We received a grant last summer for a substantial amount that's been carrying us through. It'll carry us through this March. We received another small grant from them in December, and some of that work is getting information and development out of Professor Irvine's group. So that's always good to help share that around the local business community. So we've had a pleasant experience with Scottish Enterprise. They're very open to communication. They're always contacting us to let us know there's new programs in place, and they're happy to work with us since we're in a renewable hydrogen development stage. The question about under the BEIS UK government and the competition potentially this summer, I'm not aware of that, but I'll definitely look into that to see if that's something we could be ready for. So I can't really comment about our ability to do that. The types of partners we're looking for, it's a good question. We're looking to pull in at least one strategic partner, so someone in the space, someone in the SOEC or SOFC space that understands research and development and timelines and costs, understands the potential of having a new technology in the hydrogen electrolyzer space and what the value is to that, and someone else also understands that the growth of that space, because it is you can't go by a day without getting something on a social media feed that is promoting the new hydrogen economy, either in Europe or Australia or the UK. So it's a very exciting space to be in. We think we've kind of positioned ourselves well to be ready for that. and everybody has target dates of being fully hydrogen, or scaled up to their expectations by 2030, and we think we'll be ready well before that and have a product in place to support that requirement. That's different than the either PEM or oxygen ion conductors that are out there now. So initially, we're looking for a strategic like that, as well as like a financial a bank as well. And we're in conversations with a lot of people. We've done 2 promotional videos per month for the last 3 or 4 months, and we have a long list of people we're engaged with and speaking with. So we're getting a lot of traction on that side. So, but anybody else that if is interested in a new technology like this, that understands the R&D ramp up and pace, and understands the value of a new technology like proton conducting ceramics in the SOEC field, we'd be happy to talk to them.
Could I just add one more answer to Jamie in terms of what Eden, Genesis, and the Hydrogen Accelerator can do? I think that's very much about building an ecosystem. There's lots of activities spread across Scotland and capabilities, and the more we can link them up, and things like the question about storing energy. If you link batteries to hydrogen, you can have a much more dynamic and efficient system. So the batteries can be very responsive, and you can get the time response out of the hydrogen. So I think our role is, if we can get people talking together and working together, that will be a big help. But I guess that's the challenge for the industry club.
Now, you've got a big audience today. This is impressive to have 66 people spend an hour talking about something exciting as this.
It's a good start. I'm very pleased. Well done, Sneh.
Yeah, it's a very good start. It's impressive to come out of the box with this many people.
Absolutely, and I think one of the things, sorry, this is Ian Hill from St Andrews. One of the things we've learned from this today is very much that the university can play a role in connecting companies to each other and connecting companies to university expertise, so that we are in an advanced position to respond to the BEIS calls or to the Scottish Government policy initiatives or whatever they might be. So I think one of the benefits of Industry Club is that it will allow us to create that kind of community, so that we've got good lines of communication. We're ready to jump in for some of these initiatives. Our overall ambition here is to make Northeast Fife, Dundee, Tay Cities area the go-to place for some of these kind of technologies. And if your interest happens to be slightly more in, for example, electrical systems or batteries, then there will be future iterations of Industry Club that will be focused more on those kind of technologies as well.
Okay, thank you very much. I think it's a good tradition to have 10 minutes at the end of the hour. So now just up the last slide, which is this time next month on the 24th. Guess it's a Wednesday as well. Tom Rose from Impact Solutions and Ben Todd from Marcola. So a nice balance between, one is obviously batteries and one is obviously hydrogen. Actually, it might not be as clear cut as that. We'll have to see. Safety, yeah, certainly in terms of the Hydrogen Accelerator, safety is huge, and got to be a key part of everything we do. Yeah, I think that's certainly thought to go
John,
with.
John, it's Graham here from Strathclyde. Just to add, through Hydrogen Accelerator, our involvement with you in that means we can draw on some of the wider capabilities. So I know that some of our marine colleagues who are working on hydrogen ships associated with the Marine Safety Centre. And I'm sure there are other academics as well as them that we can draw on to support some of these key areas. I think that's one of the things we can pull from the wider academic partnership.
Okay, 5 minutes to get a cup of tea before your next meeting, I guess. Thank you very much. It's been brilliant. I appreciate your engagement. Thank you.